Alright, for this first game, I have chosen to organize my data in this way. I'll group the people by the bonus they get. The $1,000 bonus people will go here, the $3,000 and the $5,000. And then for dealing with what department and whether they're effective, I've used these shaped sort of placeholders. So my finance people are squares. The highly effective ones, L and M, are circled squares. Are there other ways of dealing with that? Sure, absolutely. Here is one way, in the way that I dealt with it. So X makes more money because X is our circled triangle, makes more than either V or Z. L and M, our circled squares, make more than K or P. And ain't no triangle making a $1,000 bonus. All right, let's do this thing. A global accounting question asking for an account of all of our people and what bonuses they got. But answer choice A is bad because it has Xavier making the same amount as Vaughn and Zane. And Xavier has to make more. Answer choice B is bad because it has Zane making $1,000. We just discussed this. Graphics department don't make $1,000. They make more than that. Answer choice C doesn't have any problems. It is our answer. Answer choice D, however, has Meng, our circled square, making the same amount as Kimura. That is false. Our circled squares have to make more. And finally, answer choice E has got Vaughn making $1,000 again. Graphics departments don't do that. And that's how we deal with that first question. Question 2. If Lopez doesn't receive the same bonus as Meng, so those are our circled squares, so they make more money. So one of them is making $5,000, the other one is making $3,000, and they're both making more than the non-circled squares, so the non-circled square is here, and those are K and P. And then our triangles, well, X has to make more than V and Z, but V and Z can't make 1,000, so V and Z and X has to make more. And I'll leave the shapes off just so you don't have to watch me draw them. What could be true? K gets 1,000. No, K is here. Lopez gets 3,000. Sure, Lopez could get 3,000. Question 3. If only one of the employees receives a $1,000 bonus, what must be true? So that employee has to be a square, right? Because our triangles don't get $1,000 bonuses. And that square is either K or P. And then the other one, but that's the only person making 1,000. So the other one of K or P has to make less than L and M. So L and M, and here I am doing the shapes, have to make more than this other K or P. And then, oh, that same thing with X and V and Z. X has to make more than V and Z. V and Z never make 1,000. V, Z, X. And maybe somewhere around in here you notice that X and V and Z all have to be in their places there. And that's cool if you notice it now. It's cool if you don't notice it until later. All you gotta do is just follow the rules and everything works. So if only one employee gets a $1,000 bonus, what must be true? Well, we know L and M get 5,000, and sure enough, there's our answer choice A. And question 4 asks us what must be true. One of the ways of thinking about how E is right is like, how could you make it false? How could you make more than 3 employees get a $5,000 bonus? Well, 3 employees, those are our circled items, right? If you put more than that, then all of a sudden our circled items aren't making more than their non-circled counterparts. There's no way that we have more than 3, or to view it specifically, X, M, and L. Who else are you going to put in there? Nobody, because then V or Z is making as much as X, or K or P is making as much as L and M. For question 5, 2 of the employees get a $5,000 bonus. Well, we've now established that X always gets that $5,000 bonus. V and Z make less. And we want 2 employees, so the other one will be either L or M. And then the other one of L or M must be here. And because they have to make more than the non-circled squares. So those non-circled squares are here, K and P. And we were asked what has to be true. Peterson receives a $1,000 bonus. Yes, that must be true. For number 6, why don't we just go through why these all 4 can work? Or should we talk about why B can't? Let's do both. All right, answer choice A is totally fine. The same number get 1,000 as get 3,000. Let's have K and P getting 1,000, V and Z getting 3,000, and L, M, and X. Sure, that's fine. Answer choice C. The same get 1,000 as get 5,000. We've already seen that happen. Here's 2 and 2. D, more 1,000 than 5,000. So 2 is the most 1,000s we can get. So we'll say V and Z and L and M all make 3,000 and only X. X is more than V and Z, L and M are more than K and P. That's how you get more thousands than 5,000s. And E, more 3,000s than 5,000s. Well, we've seen that right there. And finally, for answer choice B, why can't you do more 1,000s than 3,000s? Well, the most 1,000s we can get are K and P, right? Because we can't put any triangles there. And now if we want more here, then we only get one person here. Who is that one person? Let's make it V. Now Z is over here with X. Can't make it V. All right, let's make it our circled square. Now V and Z are both over here with X, and that won't work. And that is the way it is when an answer is false. It just forces you to break rules. You can't make it work. And that's this first game.